Hi, I'm Carlotta A, and I'm an open source hardware trailblazer fellow. And my project is Robotics for the Streets, the design of flower bots so that academics can engage in service, teaching, and research. And today we will show how to wire up a PlayStation controller on the Daisy bot in order for it to be driven remotely. In order to do this, we're going to have to add an additional power supply so that we have one power supply just for the motors and then another power supply for the Arduino, the RGB LEDs, the 4 sonar, the buzzer, and the 4 other LEDs. Please come along and I hope you enjoy. So here we have the fritzing for the 2 power supplies and the PlayStation controller. The first thing you should note here is that we have a 4 AA battery pack on the left, which supplies the 6 volts for the left bus, the one furthest away from the microcontroller. And the only thing connected here is the ground and the voltage for the motor controller. And then there's one wire that connects the grounds together for the 2 buses on the breadboard. Then over here we have a 9-volt battery pack that is going to supply the power to the Arduino Mega, and it also then has a red that goes to voltage and a black that goes to ground that then supplies the power for the 4 LEDs. Then over here we have the PlayStation controller, and up here this summarizes the connections for the PlayStation controller, including that DAC goes to 13, command goes to 11, then we have 4 going to ground, we have 5 going to 3.3 volts, select going to pin 10, and the clock going to pin 12. So what you'll see here is that at the top, other than having the voltage and ground connected to the left bus on the breadboard, we have PWM B to pin 7, bin 2 to pin 6, bin 1 to pin 5, A and 1 is to pin 4, A and 2 to pin 3, and PWM A to pin 2. VN is coming from the Arduino Mega and going to VM, and the left motor is connected to motor A, and the right motor is connected to motor B with the ground at the top and then the voltage underneath. Note that if you run the code and the robot is moving backwards or spinning when it should go forward or reverse, you may need to reverse the red and black pins on the motor. Next, we have our LEDs, and what you'll see is that the yellow LED goes to pin 52 through the 330 ohm resistor. The red LED goes to pin 53 through the 330 ohm resistor. The blue LED goes to pin 50 through the 330 ohm resistor, and the green LED goes to pin 1 through the 330 ohm resistor. At the bottom, we have our left, right, front, and back sonar. The left sonar trigger goes to 58 and echo goes to 49. The right sonar trigger goes to 46, echo goes to 47. The back sonar trigger goes to 42, echo goes to 43. And the front sonar trigger goes to 44 and the front echo goes to 45. Finally, we have the buzzer. On the buzzer, one lead goes to A3 and the other one goes to ground. For the RGB LED, the longest lead goes to ground, and then the lead next to the ground is the red lead through a 330 ohm resistor. It goes to A2. Then the green lead through a 330 ohm resistor goes to A1. And finally, the blue lead through a 330 ohm resistor goes to A0. Let's see what this looks like on the robot. In order to have enough power on the Daisy bot to run the PlayStation controller, this is the controller, and this is the Bluetooth dongle for the PlayStation controller. We had to add dual power supplies, so I will walk through the new wiring diagram. So first, if you now look under the robot, there's a 9-volt battery pack on top that's black and a 4 AA battery pack on the bottom. The 9-volt battery pack is used to power the Arduino Uno, the 4 sonar, the 4 LEDs, and an RGB LED. So all of those are connected to the bus closest to the Arduino Uno. The 4 AA battery pack is connected here, and it's used on this outer bus to power only the motor controller, which will power the motors. So if you notice, the only thing connected to this bus is that battery pack as well as the 5 volts and the ground to the motor controller. And now everything else is wired the same. So if you look, we still have the yellow, red, green, and blue LEDs going to the left power supply, but on power bus. We also have an RGB LED. All of them are in series with 330 ohms. It's also important to make sure that you disconnect the red wire that was connecting the left and right buses on the breadboard. So there's only one wire that connects the buses now, and it's that gray wire that ties the two blue buses together so that they have the common ground, but they no longer have a common voltage because one is coming from the 9-volt and the other one is coming from the 4 AA batteries. Other than that, everything else is still wired the same. And I will show separately the Bluetooth dongle wiring, as well as the wiring for the motor controller, the LEDs, and the 4 sonar around the robot. So the new additions with the double power supplies, the first one is we will have a buzzer for testing sensor connections. One side of this buzzer will go to ground, and the other one will go to A3 through that white wire. We're going to talk about the wiring for the RGB LED. So the RGB LED has 4 leads. The longest one is ground. And what you should see here is that ground goes to ground through that brown wire. Then next to that is the red LED that goes to a 330 ohm resistor to A2. Then the green LED goes through a 330 ohm resistor to A1. And then the shortest lead is the blue LED lead, and that goes to A0 through a 330 ohm resistor. So there's the RGB LED. So here's the RGB LED. And then here you have the red wire that goes from the red lead to A2. The white wire goes from the green lead to A1. And then the blue wire goes from the blue lead to A0. So A0 is the blue lead, white is the green lead, red is the red lead, and then this white wire is coming from the buzzer going to A3, and then the other side of the buzzer is going to ground. Now let's write the code.